Hello children, welcome back to the second video of electricity chapter, and in this video we are going to learn about Ohm's law, resistance, factors affecting the resistance of the conductor and the resistivity. Okay, let us begin the next bit of it. Children, the most famous German physician and mathematician, that is George Simon Ohm, he was born on 16th March 1789. He has discovered that there was some proportionality between potential difference voltage and applied current over the conductor. Okay, we can see that there was a relationship between the potential difference and the current in the conductor. It was being given by Ohm's law. Ohm's law actually explains the relationship between the voltage, current and the resistance. He has used many electricians, automotive technicians and stereo installers to find out the relationship between these three things. He has conducted many experiments and he stated that according to the Ohm's law, at constant temperature, means there is no change in the temperature, the current flowing through the conductor was directly proportional to the potential difference across its ends. What does this mean? So he has conducted many experiments. He had taken one circuit and started the current to flow through the conductor. As he changed the potential difference in that conductor, there was a rise in the flow of current also. Means as he increased the current for what you call potential difference, there was a rise in the current also. Means current was also increasing. So from the values after conducting several experiments, he has concluded that the current and the voltage was directly proportional. As the current was increasing, or you can say potential difference was increasing, the voltage was also increasing. So at the end he stated that voltage V was directly proportional to the current, but it was not equal. If it was 2 volts, current was not 2 amperes, but it was increasing. But from that he stated that it was directly proportional, and with that directly proportional he took out that proportionality constant as R. So V was equal to R into I. What is this R? R, he named it as that constant, he named it as resistance of the conductor. There was a factor which was affecting the flow of current in the conductor. What was that? That was resistance. What is this resistance? We will discuss it, but this can be written as, this equation can be written as I equals to V by R. So where V is voltage and R it is resistance. So I it is given by V by R. So from this we can say that the current is directly proportional to the voltage across the conductor and it is inversely proportional to the resistance. What does this mean? As the voltage increases, the current will also increase. But whereas if the resistance increases, the current will not increase, it will decrease. Why? Because it is inversely proportional. Okay, you have to remember this one, children. So we will discuss what is this resistance, what is that factor which is affecting. So I will explain you in this way. Resistance is the hindrance to the flow of electrical charges. Means you can see the diagram over there, the charges are flowing and someone is stopping that one. Resistance is nothing but the stoppage or hindrance. You can say there is a disturbance or stoppage in the flow of current, that is called as resistance. You can say hindrance in the flow of electrons or charges. For the electrons, the journey from one terminal to other terminal is not direct route. It will not go directly, but in that what you call, I'll explain you in this way. So suppose I'll just take one wire here. I'll draw it on this slide itself. Suppose now there are some electrons, okay, so which are going to flow now, and there are also not only electrons, atoms will also be there in between. What happens? These atoms will not allow directly to the electrons to flow. What happens? There will be a collision. I'll give an example. Suppose, okay, in your school, if there is a corridor, and your classes are here, and once the bell rings, what will happen? You will start running to your classes, okay, because the bell has rung. Now as you are running to your classes, what happens? There are other students who are also going. Now what will happen? In between the road, we will not go with the same speed. What happens? Because of the collision with the other students, what you will do? Your speed decreases. that what there will be hindrance in the flow, what you call when you are running, because there will be a collision. That collision, or because of which you will change your path and go like this in a zigzag way, because of which the speed of your flow of the, or you can say speed of your moving, that decreases. In the same way, as you reach the class, it takes a little bit of time when there is a disturbance. When there is empty route, then there is easy, you can say, in that corridor you can move it very easily when there is no one. But when there are many other students, you will collide with them. You will not just pick them up and you will not take them along with you. But whenever there is a collision, what happens? You will stop down from there. When you stop, what happens? There is some disturbance set up in the flow of the current. Similarly, here also, what happens when there is electrons are flowing? What happens? They will not stay at one position. What happens? Because of the collision between the atoms, other atoms. Because of that, what happens? There will be decrease in the flow of current. This resistance describes that disturbance. Disturbance in the flow of current, you can say, or hindrance in the flow of current, you can say. This is called as resistance. It is a zigzag path that results in the countless collisions, because other atoms will also be there. Because of that collisions, what happens? The hindrance will be there in their movement, that it is called as resistance. Now, certain conductors will have their own resistance, and we are using some devices to create a resistance. Sometimes we do not need much current. To decrease the flow of current, we are going to use some devices like resistors. Okay, they are called as resistors, and these devices what you are seeing, they are called as resistors. And there are some factors which are going to affect the resistance of the conductor. Okay, now you can see the diagram over here. These are nothing but the types of resistors which you are connecting in these circuits. You might have seen in the what you call your chargers and many toys, electrical toys, you might have seen, cars and all. Everything has some resistors. Okay, the factors which affect the resistance of the conductor are: first one, length of the conductor; next, area of cross section of the conductor or thickness of the conductor. Okay, so how it will depend, I'll just tell you. First we will read out these. What are these? Nature of the material, means what is that material made up of. Okay, next, temperature of the conductor. Now, first thing, which is length. So resistance depends on the length of the conductor. See, as the length increases, the path of the electrons, it will become more. As it becomes more, what happens? Suppose there is I'll take two roads. Okay, suppose there are two roads and the race starts from here. Now if it is the same road, you may get a possibility that on a bigger road you will get more number of speed breakers, right? As the length increases, the number of speed breakers will also increase, whereas in smaller road you can get very least amount of what you call resistance, that is speed breakers. So similarly, in electrical current also, as the length of the conductor increases, the collisions become more. Okay, whereas if the length is small, the collisions will be very less. Therefore, as the length increases, the resistance is also increases. Remember this, children. So length is directly proportional to, you can say, resistance of the conductor. And area of cross section. Now suppose, resistance depends on the area of cross section also. Suppose there are two pipes which has which has more diameter and another. There is a tank over there. Okay, suppose there is a tank and there are two types which has one has more diameter and the other has smaller diameter. So can you say in which tap the water will flow very easily outside? So obviously you will say the tap which has more diameter. Why? Because it will be having more space to pass the flow of water, right? Similarly, in electrons also, if the thickness of wire, you can say thickness of wire is more, okay, then the electrons will flow easily. So therefore, as the thickness increases, resistance will decrease. So area of cross section is inversely proportional to resistance, or resistance is inversely proportional to area of cross section. You can say resistance is inversely proportional to area of cross section. How? As the thickness is more, the resistance will be less. They will go flow around, they will pass it from there. Okay, right. Similarly, whereas in a wire or in a conductor which has very small area of cross section, means thickness of the if wire is very less, so their collisions will be more, so resistance is inversely proportional to area of cross section and resistance is directly proportional to the length. Next comes one more thing, that is nature of the material of the conductor. What is this means? Nature means what material that conductor is made up of. Different metals will be having different resistivity. Okay, resistance is also directly proportional to the resistivity of the conductor. Okay, resistivity means we will discuss it now, but remember resistivity is nothing but the nature of the material, means how of which material that conductor it is made up of. Okay, the last thing is temperature of the conductor. So temperature of the conductor means, so if the temperature increases, what will happen? So suppose if the temperature increases, you might have seen in the sunny summer season, as the temperature increases, the electrical poles of the wires, they will start hanging down. Instead of being tight, they will just hang down. Why? Because the length of that wire increases because of temperature. There will be a thermal expansion, linear expansion in the conductors. As the linear expansion is seen, because length is also increasing, and we know that resistance is directly proportional to the length of the conductor. So if the temperature increases, the length also increases. If the length increases, the resistance is also going to increase. This is how the temperature is dependent. Right now we are not including as a temperature as one of the factor to find out the formula. So R, it is given by, see, R we have taken as R is directly proportional to L, R is inversely proportional to A, and R is directly proportional to rho. We are combining all these and we are going to write it. So R is equal to L, R is directly proportional to L upon A. This equality symbol we are going to convert it to one of the factor, that is rho L upon A. So we are going to write that formula to calculate the resistance. It is rho L upon A. Now you can see that on the screen. It has been found by the experiment that resistivity of the given conductor is directly proportional to the length of the conductor. So as we have written, R is directly proportional to the L. Second, the resistivity of the given conductor is inversely proportional to area of cross section. Means we have written it. As we have seen, that thickness is also dependent. The resistance is depending on the thickness. If thickness is more, resistance will be least. If thickness is less, so then only you are going to find out the more resistance over there. Okay, by combining these two, we are going to write R, it is equal to L upon A. So this, to remove this proportionality symbol, we are writing this symbol, this rho. This, as you can see, the P, like we have written, that it is called as rho. Okay, when you are writing, you can write in this way. We can write the symbol in this way also. Okay, so we can read it as rho R H O. You are going to read that symbol as rho. Okay, you are going to read this symbol as rho L upon A. Okay, this is the formula to calculate the resistance or resistance of the conductor. Okay, resistivity, you can rewrite it. Rho can be written as R into A L upon L. You can write. Okay, this, if you rewrite this one, rho can be written as R into A divided by L. Okay, say similarly you can rewrite according to the whatever use you want to find out. Okay, so this is all about resistivity. Okay, there are some factors, one more factors. You can say, see, they have rewritten that one. Rho can be rewritten as rho, it is equal to R into A divided by L. Okay, rho's SI unit is ohm meters. Why? The SI unit of resistance is ohm. It is calculated in ohm, measured in ohms, and the SI unit is given by ohm meters. You can say, how ohm meters? You can see here, resistance SI unit is ohm, and area of cross sections, it is given by ohm meter. See, rho we are going to write, resistance SI unit is ohm, and area of it is given by meter square, and length it is given by meter. So this meter and this square will get cancelled. Rho it is left. The rho it is equal to ohm meter, it will be left. So SI unit of resistivity is given by ohm meter, you can say. Okay, so this is all the about resistivity, you can say. Next thing which comes is this table, which has given some resistivities of the material. You can see in the table the material which has the least resistivity is 1.60 and to 10 raised to minus 8, and similarly here it has these insulators here, they are going to have the maximum resistance over there. Okay, you can just refer the textbook for this table. It has been given in your textbook, children. Okay, so these are the few tables in the few materials only he has given. He has not given all the things. Now resistivity of an alloy are much more than those of the pure metals. So you can see that resistivity of alloys are much more than that of pure metals. And for example, the resistivity of the magnine is a alloy which is alloy of a copper, manganese and nickel. It is about 25 times more than that of copper. So the resistivity is 25 times more than that of copper. You can say alloys are having more resistance. Alloys are used in making heating materials such as your whatever heaters are there, welding machines are there, and many other things which we need more heat. That kind of materials, for that devices we are using this heating materials. Okay, alloys are very high resistivity, having very high resistivity, and due to which heating element produce a lot of heat on passing the current. So when you pass the current through them, a lot of heat will be produced. And alloy do not undergo oxidation easily even at high temperature. Why? Because so these are combined a mixture of other many metals. Okay, because of which they will not undergo oxygen. They will not react with oxygen easily at high temperature also. These are all the things which are the properties of a you can say metals which are having high resistivity. Okay, so this is all about resistivity. The combination of resistors we are going to study now. The resistors can be combined in two ways. Okay, so resistors are usually combined in two ways. One is in series and other is in parallel connection, children. So when you see this one, okay, so usually at your homes either some series connections will be in series and mostly at your homes they will be in parallel connections, children. Okay, so now let us study one by one. What are these series connections and parallel connections? When the resistors are connected end to end, see R1 beside R2 and R beside R3, they are connected end to end. Such connection you call it as series connection. Okay, so you can see they have been connected one after the other. Whereas in parallel you can see R1, it is R2 and R3, all the ends are connected to a common point here. So these, when they are connected to a common point, they call it as a parallel connection. Okay, so you can say resistors in series and resistors in parallel. Okay, when two or more resistors are connected end to end consecutively, means one after the other, they are said to be connected in series. Okay, so now you can see, I'll just show you one diagram over there. See, you can see here R1 connected to R2 connected to R3. So as you can see, this one you are going to see voltage source, they are going to, voltmeter they have connected. Okay, usually it is connected with the batteries. Here in series connection, the current is not going to divide because it has a single path. Current will go in a single path. That's why what happens here, the current is not going to divide in the series connection. But whereas the potential difference is going to get divided because it is not directly connected here. As it is, they are not connected directly to the battery. That's why what happens, the R1 resistance will have a different voltage and the R2 will have a different voltage and the R3 will have a different voltage. You have to remember, in series connection, the resistor, what you call, the voltage will get divided. Okay, so voltage is going to get divided, whereas the current will not get divided. Whereas for in resistance in series, we are having only one switch for all the appliances. If you switch on one button, all will get off. Okay, this is what the specialty is. If you switch off one button, then all the appliances will stop working. But whereas, see, if here also one more thing, if any one of the component fails here, if resistance 2 fails, R1 and R3 will also stop working. If R3 fails, R1, R2 will stop working. If R1 fails, R2, R3 will stop working. This is also the most important point. If one appliance fails, then others will stop working. Other appliances will stop working here. These are the few properties, or you can say few characteristics of resistance in series, children. And the total resistance is calculated by R1 plus R2 plus R3. And we are going to show it to you how we are going to calculate. See, R1 will have the resistance will have current V by I. Okay, so we'll just show it to you. Now you can say the total resistance is equal to the sum of all the individual resistances. Okay, when the number of resistors connected in series join the terminal to the battery, each resistance has a different voltage. As we can see, as I have told you already, that the potential difference for each resistance will be different, but the total potential difference across all the ends will be in series will be equal. If you add the total voltage V1 plus V2 plus V3 will be again same what you have supplied. Okay, when number of resistors are connected in series, then the same current flows through each resistor. So current is not going to divide here, so same current will pass through R1, R2 and R3. Okay, let us see how they are going to calculate it. As you can see on the screen that total voltage is given by V, it is equal to voltage V1 plus V2 plus V3. As we have taken here, total voltage is equal to V1 plus V2 plus V3, and we know that according to the Ohm's law, V equals to IR. So we are having different resistances R1, R2 and R3. So we are going to place in place of V1 R1, V2 R2 and C. I can say V1 it is equal to IR1 because V is equal to IR. Just we are taking in place of V1 IR1 we are going to take. For V2 IR2 and for V3 IR3 we have taken, because for V1 I into R1, I will remain constant, we know that one. That's why we are taking I for all three. V1 is equal to IR1, V2 is equal to IR2 and V3 is equal to IR3. And when you just add them up in this one, okay, we are going to substitute in this value in place of V1, V2, V3, and we have V is equal to IR, we are going to place in this V part IR, we have kept it. Okay, in place of V1 we are going to keep it as IR1, in place of V2 we have kept IR2, and in place of V3 we have kept IR3. Okay, so when you substitute all these things, we can see that IR it is equal to I, we are going to take a common here. As you can see, I can be taken in all the three parts. What is left in bracket? It is left as R1 plus R2 plus R3 it is left. Now I is on the both the sides, it get cancelled. What is left? R it is equal to R1 plus R2 plus R3 it is left. So the total resistance is given by R1 plus R2 plus R3 in a resistance series. So we are going to calculate the total resistance by adding up all the individual resistances. How to calculate when many resistances are connected? So many resistances are connected, if they are connected in series, we are going to add them up all. Okay, R1 plus R2 plus R3 will give total resistance of series connection. Now resistors in parallel, what does this mean? When these resistors are connected in parallel, what happens? They are said to be parallel when they are connected between the same points. Okay, I have shown you the diagram. I'll just show you that when they have been connected, you can see R1, R2 and R3 have been connected to the same terminals. You can see here this terminal R1 is also connected to this R2 and R3, and ends of these are connected to the same terminals. Such connection you call it as a parallel connection. Okay, so according to the law of combination of resistance in parallel, the reciprocal of the combination of resistance of any number of resistances connected in parallel is equal to the sum of reciprocals of individual resistance. Means 1 upon R it is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus and so on. Means how many resistances are there? That many we can add up over there. But total resistance is given by this formula. So we'll derive that one. Okay. So when the number of resistances are connected in parallel, their combination resistance is less than the smallest individual. Suppose there we are having a 2 ohm, 3 ohm, 4 ohm resistances. Suppose we are having a total 1 ohm, 2 ohm and 3 ohm. So if you want to calculate the total resistances, so 1 upon R it is given by 1 upon 1 plus 1 upon 2 plus 1 upon 3. If you just take, if you take the LCM over there, what you are going to get? 1 upon 6 you can take. You are going to get a LCM as 6, because 1 6 are 6, 1 2 3 are 6 and 3 2 are 6. 6 plus 3 plus 2 it will be 11, and LCM will be 6. Okay, now if you take the reciprocal 1 upon R, now R it will be equal to, if you take a reciprocal of this R by 1, so you are going to get 6 by 11 over there. So 6 by 11 is again less than 1 over there. You can see the total resistance, it is less than that of smallest individual resistance. Smallest individual resistance was 1 ohm. We are getting the total resistance less than that of 1 ohm. So in this is the specialty of parallel resistance. We are going to get the least resistance over there, whereas in the series connection we have seen that we are getting a maximum resistance. Suppose we were having a resistances as 1 ohm, 2 ohm and 3 ohms. We are going to add them up. If we add them up, total 6 ohm we are going to get. So 6 ohm resistance we are we are going to get over there, right? Fine. So totally in series resistance we have seen that maximum resistance we are getting, but whereas in parallel connection we are getting very least number of resistances. When the number of resistances are connected in parallel, then the potential difference across each resistance is same, in which the voltage battery is applied. See here, you can see here, now current it is getting divided, as it is getting 3 paths here. It should enter from here also, as well as here, as well as here. But whereas the potential difference will remain same over there, because they are connected to the same point, same terminals over there. Okay, so I1, I2 and I3, if you add them up, total current will be equal. So when the number of resistors connected in parallel are joined to the 2 terminals of the battery, because as they are connected directly to the battery, so therefore the potential difference is not going to divide it here. So this is the current flowing through each parallel resistance taken together is equal to the current flowing in circuit as a whole. If you add them up, I1 plus I2 plus I3, the total current will be equal to I. Okay, when a number of resistances are connected in parallel, then the sum of the current flowing through all the resistance is equal to the total current flowing through it. Okay, this is what we are saying. Total current is equal to I1 plus I2 plus I3. So how to find out the total resistance, total volt of the parallel connection? How to find out the total resistance of a parallel connection? So I it is given by I1 plus I2 plus I3, and VI it is equal to V by R we have got by Ohm's law. We are going to substitute these values. Okay, I equal to I1 plus I2 I3 we are going to take, and I it is equal to VR. So in place of I1, V by R1 we are going to take, in place of I2 we are going to take V by R2, and in place of I3 we are going to take V by R3. Why? Because it is been current in R1 will be V by R1 into R2 V by R2, and in R3 we are going to take V by R3 current as. Okay, substituting the values in this equation, I equal to I1 plus I2 plus I3. I equal is given by V by R, and I1 is given by V by R1, V by R2 plus V by R3. If you take V as a common in all these 3 things, we are going to see that V by R1 plus R2, 1 upon R1 plus 1 upon R2 plus 1 upon R3 will be left. So V will get cancelled. What is left? 1 upon R it is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 will be left. Okay, I'll just write it over here to simplify it. Okay, so we have taken V by R, it is equal to V by R1 plus V by R2 plus V by R3. Okay, so V by R3 we have taken. So when you take it, so V by R it is left. So V by R, so it is left V common. If you take V, 1 upon R1 plus 1 upon R2 plus 1 upon R3 will be left. Okay, so now with this this will get cancelled. What is left here? 1 upon R1 will be left, and this side 1 upon R1 plus 1 upon R2 plus 1 upon R3 will be left. So this will be the total formula to calculate the value of total resistance in a parallel connection. And we should remember that the sum of total resistance in parallel resistance connection is equal to the sum of reciprocal of all the resistances. Now we are going to see the differences between parallel and series connection. What is the difference between parallel and series connection? If one electrical appliance stop working due to some defect, then all the other appliances keep working normally. So here in parallel connection, see, as you can see, if one stops, as they are connected, others they are connected directly to the battery, then they will keep on working normally, children. And they are having different path, they will be having different switches, children, for switch on certain. For example, at your home you are having different button to switch on fan, bulb, and power plug. Okay, whereas we are going to see different switches are there. Means it doesn't mean that if we switch on one button all the appliances will start working. No, if you don't want fan, you switch off the fan button, right? So if you switch on the light, the fan will not on, right? So similarly what happens here, different appliances will be having different switches. And if one stop working, because if suppose if your bulb stops working, but fans will keep on working, TVs will keep on working. Why? Because they will be having different switches, and they are directly connected to the power source. But whereas in the series connection, they were not connected directly to the battery. That's why if one was failing, others also stopped working. Okay, in series connection, if one electrical appliance is stop working due to some defect, then all the appliances will stop working. Okay, second point, in parallel circuit, you can see each electrical appliance has its own switch, due to which it can be turned on or off independently. As I said, it is having on their own switches. Now you can use different buttons for different appliances. Similarly, but whereas in series connection, all the electrical appliances have only one switch, due to which they cannot be turned on or off separately. Best example is, I can give you fuse. If the fuse breaks, all the other appliances will stop working at your home, right? So fuse is connected in series at your homes. Okay, next, in parallel connection, each appliances get same voltage as that of power source. Okay, because they are connected directly to the source, that's why each appliances will get same. But whereas in series connection, the power voltage gets divided. Okay, whereas in parallel connection, current gets divided. In series connection, current will not get divided. This is the thing you are going to remember. In parallel connection, voltage will remain constant. In series connection, voltage get divided. So you have to remember this one. So overall resistance of the household circuit is reduced, due to which the current from the power supply is high. So what happens over there? In parallel connection, as there will be resistance, that resistance will be minimum. That's why their power supply will be more, because we have studied that resistance, if it is less, we are going to get more power, more current we are going to see. That's why in parallel connection, we are going to get a high power supply also. Whereas in series connection, overall resistance of the circuit increases. As the resistance increases, what happens? The current flow start decreasing. So to which the current from the power source is low. So what happens there? The current flow will become very less over there, children. Okay, these are the few differences between parallel and series connection. In the next video, we are going to study next bit of this topic.